All right, guys, today we're going to talk about changes of matter and properties of matter. Let me just make sure. Yep, we are recording. Okay. So, properties and changes of matter. This is our 4th week of online learning. Today we're going to watch 2 videos that are pretty short. This shouldn't take too long. At this point, you should have your science video assignment that goes along with this, that has questions about this particular presentation. I would get that out now and fill it out as we go through the slides, so that way you don't have to answer the questions later. If you do this as you are watching, then it's going to help you to get this done quicker and make more sense. So matter is anything that takes up space. So that is the definition of matter. So if somebody asks you what is matter, you would say it's anything that takes up space. So examples of matter would be air, water, rocks, people. Anything you can think of that takes up any kind of space in this world is matter. Matter is made up of atoms, if you did not know that. So inside each little bit of matter, there are atoms that are making it up. Matter can exist in 3 forms or states. And I will say there's actually a 4th form called plasma, but we're not going to get into that right now. That will come later on in your science careers. Today we're just going to focus on the 3 main ones, the basic ones. So those would be solids, liquids, and gases. So for liquids, we've got some examples. We've got orange juice, water, and milk. I know a lot of stuff that is on the worksheet is on this slide, this page, so make sure to check for some questions that relate to that. When you think about matter in a liquid state, it has a set size or amount, but its shape is dependent on its container. So for example, if you think about juice like in a juice box, the juice that's inside of that box is in a box shape. If you were to pour the juice into a cup though, then now that juice would take on the shape of a cup. So whatever container the juice or the liquid is in, that is what shape that liquid will be in. And as soon as you put it into another container, it will change shape. However, no matter what container you put it in, the juice from the juice box, the amount will always stay the same. It never gets larger or smaller. Some examples of solids would be rocks, people, books, baseballs. In a solid state, matter does have a set size and it does have a set shape. The solid size and shape do not easily change. Something has to happen to it. Either has to be broken or smashed, and that's the only way that those solids can change shape. So for example, if you take a book and there's a book that's in like a big box, and then you take that book and you move it to a smaller box, the size and the shape of the book remain the same. Nothing has changed it. It's going to be the same shape no matter what, unless you were to break it. And then finally we have gas. Some examples of gas would be air and helium, which is the gas that fills up a balloon and makes it float. In a gaseous state, matter does not have a set size or a set shape. It will expand to fill a larger container, or it can be squeezed into a smaller container. So for example, when you blow air into a balloon, as soon as you put some air into that balloon has become full of air, and every little area and empty space inside that balloon has air in it. But if you blow more air into the balloon, the lack of extra space causes the balloon to stretch. So that's why like water balloons, for example, if you were to pop it really quickly, you would see that the water fills up that shape. And it's the same thing for air. The air would fill up that shape as well. States of matter. Matter can change from one state to another. This will happen when one substance is heated or cooled to a particular point. Heat causes liquids to evaporate or turn into water vapor and gas. An example of this would be if you put a pot of water on the stove, the water is going to boil eventually. Once the water boils, you notice how like steam or water vapor comes up out of the pot. That is gas. And so because that water has gotten so hot, the liquid water has turned into gas water or water vapor. When the liquid is cooled, the gas will turn back into a liquid. So for example, if you ever put your hand over a steaming pot, or if you put your glasses in the steam, you know that that water vapor, that gas is going to be cooled by your body's temperature, and now your glasses or your hand is going to become full of liquid and covered in water, and so that is a gas turning back into a liquid. The process of liquids turning into gas is called evaporation, and then of course the process of gas turning into a liquid is called condensation. If you cool the liquid enough, the liquid will become a solid. So for example, if you take water and put it into the freezer, it will turn into ice, which is solid. Down here, we have some more information for you. The temperature that a liquid turns into is called, when a liquid turns into a gas, is called its boiling point. So water boils when it reaches 212 degrees Fahrenheit. Each substance or each different type of matter has a different boiling point and will start to boil or turn into a gas at a different temperature. The temperature that a solid turns into a liquid is called the melting point. So for ice, the melting point is 32 degrees. So if you have an ice cube, a solid, and you put it onto the hot sun, once that hot sun makes that ice be 32 degrees, then it will start to melt. And then the temperature that a liquid turns into a solid is called its freezing point. The freezing point of water is 32 degrees. So if you were to take liquid and water and put it into the freezer, once it reaches 32 degrees, it would melt. Now, if you notice here, the melting point of ice and the freezing point of water, aka they're both a type of water, is 32 degrees. For most substances, the melting point and the freezing point are going to be the same. And the reason that is because if you think about it, if you have water that's just about to turn into ice at 32 degrees, but then you suddenly take it out, it's going to start to melt also. Or if you have an ice cube that's 32 degrees, it's frozen, and you can take it outside and it can get a little bit warmer and start to melt, and you can throw it back into the freezer, and at 32 degrees it would start to become a solid again. So the freezing point and the melting point are actually usually the same, just depends on what kind of temperature it's being exposed to. Okay, this is in your book, States of Matter. This will help you when you come to your drawing portion of your assignment. If you notice in the solid state, all of the particles are very tightly packed. They're also in a regular pattern. In this situation, they're in rows and columns. They are not able to move around very much, and they're very, very, very close together. So that is a solid. A liquid, the particles are close together, and there's no regular arrangement, which is what allows you to slosh water around. And there is not really a regular arrangement. They're kind of all over the place. Gas, however, the particles are very separated, and there is absolutely no regular arrangement. And if you notice around the gas particles, there's like some little lines. That's to show that it's moving. So gases are constantly moving. And if you were to take the lid off of a gas, the gas would immediately flow out into the open space and would no longer be together. Liquid, of course, if you take the lid off of a container of water, unless you tip the water upside down, the water will stay in the container. Nothing's going to cause the water to go out if you just leave it alone open on the table or the desk. So something else to remember.
Smile and learn.
Here about the states of matter.
That's it. Perfect. They'll be ready in no time. Hey there, I'm making some more popsicles to sell. They taste so good. I'm sure they'll sell really fast. These are ready. See? They've become solid because I put them in the freezer. Have you ever heard of the word solidification? It's one of the changes in states of matter. There are more changes, don't worry. I'll explain all about them.
These are ready.
You already know that matter exists in three states: solid, liquid, and gas.
Solidification?
A change in state happens when we heat or cool
There are
matter.
more changes, don't worry. I'll explain all
If
about
we heat
them.
solid matter, it becomes a liquid.
You
We call
already
this
know that
process
matter exists
fusion.
in three states: solid, liquid,
If we heat
and
liquid
gas.
matter, it becomes a gas.
A
We call
change in
this
state
process
happens when we heat or
vaporization.
cool matter.
These
we
two
heat solid
processes
matter,
can
it
occur
becomes a
the other
liquid.
way around.
We call this
This
process
happens when we cool
fusion.
matter instead of applying heat. If we cool
If
a
we
gas,
heat liquid matter,
it becomes a liquid.
gas. We call
This
this
process
process
is called
vaporization.
condensation. If we freeze
These
liquid
two
matter, it
processes
will
can
become a
occur
solid.
the other
This
way
process is
around.
called
This happens when we
solidification.
cool matter instead of applying heat. If we cool a gas, it becomes a liquid. This process is called
Oh
condensation.
no, the popsicles have melted. I
If
completely
we
forgot
freeze
about
liquid
them.
matter, it will
Do you
become a
remember how
solid.
we
This
call the
process is
change from
called
solid to
solidification.
liquid? Fusion. When a solid becomes a liquid, it's called fusion. When the temperature of a solid
Oh no,
rises,
the
the
popsicles
particles
have
that make up
melted.
matter
I
start
completely
detaching
forgot about
from
them.
one another
Do you
and
remember
move
how we
more
call the
freely.
change from solid to liquid? Fusion.
See?
When a solid becomes
Liquid
a
turns
liquid,
into
it's
gas
called
when heated.
fusion.
Do you remember how we call
When the
this
temperature
process?
of a solid
When a
rises,
liquid becomes
the particles
gas,
that
it's
make up
called
matter start
vaporization.
detaching from one another and move more
When
freely.
a liquid is heated, the bonds among the particles that make up
See?
matter become more
Liquid
loose.
turns into
So
gas when
particles
heated.
move around
Do you
freely.
remember how we call this process? When a liquid becomes gas, it's
What if
called
I cover this
vaporization.
pot? What do you think might happen? Water
When a
vapor
liquid is
cools
heated,
as it reaches
the
the
bonds
lid,
among the
and
particles
its
that make
state
up
changes
matter
from gaseous
becomes
to
more
liquid.
loose. So
Do you
particles
remember
move
how we
around
call this
freely.
process? I've just told you, haven't I? The change from
What
gaseous
if I
to
cover
liquid
this
is called
pot?
condensation.
What do you think might happen?
As a
Water
gas
vapor
cools,
cools
the
as it
particles that
reaches
make
the
up
lid,
matter start
and
coming
its
closer
state
to one
changes from
another
gaseous to
and move
liquid.
around more slowly.
Do you remember how
This
we
will
call this
continue to
process?
happen till matter
I've just told you,
solidifies
haven't I?
completely.
The change from gaseous to
I
liquid
think the
is called
popsicles I
condensation.
froze up earlier are just about
As
ready.
a gas cools,
That's right.
the particles
I
that
put
make
some
up matter
popsicle
start
molds
coming
in the
closer
freezer
to
a while
one
ago.
another
The
and
liquid
move
in the
around more
mold must
slowly.
have frozen up
This
by
will
now.
continue to
The
happen
change
till
from
matter
liquid to solid
solidifies
is called.
completely.
Come on, you know this.
I think the
told you
popsicles
before.
I froze up
It's
earlier are
called
just about ready.
solidification.
That's right. I put some
During the
popsicle molds in the
solidification
freezer a while
process,
ago.
the particles that
The
make
liquid
up
in the
matter
molds
lay
must have
very
frozen
close
up
to
by
one
now.
another and
The
move
change
less
from liquid
and
to
less.
solid is called. Come on, you know this.
These are the
I told you
changes in
before.
the states of
it's
matter.
called
Let's recap.
solidification. During the
If we
solidification
heat solid
process,
matter,
the
it
particles
becomes a
that make up
liquid.
matter lay
We call
very
this
close to one
process
another
fusion.
and move less and less.
If we heat liquid matter, it
These are
becomes
the
a gas.
changes in the
We call
states
this
of matter.
process
Let's
vaporization. These two
If we heat
processes can
solid
occur
matter,
the
it
other
becomes
way
a
around.
liquid. We
That
call
happens
this
when we
process
cool matter
fusion.
instead of applying heat. If we cool
If
a
we
gas,
heat liquid matter,
it becomes a
a
liquid.
gas.
This
we call
process
this
is
process
called condensation.
vaporization. These
If
two
we
processes
freeze liquid
can
matter,
occur
it will
the other
become a
way
solid.
around.
This
that happens when
process
we
is
cool
called
matter instead of
solidification.
applying heat. If we cool a gas, it becomes a liquid. This process is called
Now
condensation.
you know all about the changes in states of matter.
If we
I hope
freeze
you
liquid
find what you've
matter,
learned
it will
useful
become
in
a
class.
solid.
I have
This
to go.
process is
Look at all those
called
people lining up for
solidification.
popsicles. See you around.
Now you know all about the changes in states of matter. I hope you find what you've learned useful in class. I have to go. Look at all those people lining up for popsicles. See you around.
All right, so that kind of gave you some visuals for how the particles move around, and some review of the terms that we talked about. All right, so changes in state. So this is kind of what she's talking about here. When you heat a substance, the energy or the heat added to the substance makes the atoms in the substance move more quickly. As the substance heats up, the atoms move faster and break free from the rigid structure of the solid, causing the substance to melt into a liquid. And that's how a solid changes into a liquid. Liquids go into a solid by when you cool a substance, the atoms are going to start to move more slowly, and then eventually they're going to stop moving completely and become a solid. For a liquid into a gas, the water is heated or the liquid is heated, and then it's going to turn into a gas during the process of evaporation. For gas into a liquid, the water or the liquid is going to cool, and it's going to turn into a liquid during condensation. So here now we're going to talk about physical properties of matter. So a physical property is a characteristic of matter that can be observed and measured without actually changing the matter itself. So for example, if you were to observe an apple, you can look at the apple and you can talk about the different characteristics about it without having to change the matter or do anything to it. You can just look at it, you can smell it, you can taste it, you can feel it, you can talk about the shape or the color. You don't actually have to physically change the apple itself. If you cut it up and you taste it, it's still going to be an apple. So you can also learn about matter by measuring physical properties, such as the size of it, the mass of it, and the mass is how much matter is in the object, the weight of it, the length of it, and then the temperature of it. So these are physical properties. Again, these are things that can happen that you can observe without changing the actual thing itself. Chemical properties, on the other hand, talk about the ability of a substance to change into a new form of matter. Excuse me. So some examples would be things that react with oxygen. So an example of that would be like iron rusting or metal rusting. If you are to leave a car outside in a field for months and years on end, eventually that car would develop rust and would wear down. And that rust actually is a chemical change that occurs because the car is now in a different form. It's a different substance and a different type of matter, and you can never get it back to the original car unless you replace and get a brand new part. Flammability, or the ability to burn. If you are burning oil or gas, or if you put dry wood into a fire, or if you light a match, that's an example of a chemical property. And then finally, reactions with acids or bases. So structures that are destroyed by or damaged by acid rain. And here an example of this is, maybe you guys didn't know but obviously this is the Statue of Liberty here at the bottom. When the Statue of Liberty was first created, it was actually copper. So like this gold color here on the bottom of the screen that says 1886. The copper, which is the gold metal, the goldish colored metal, reacted with the oxygen in the air and has now turned green, obviously, because the Statue of Liberty is green. Maybe you guys have seen a penny before that has like little green bits on it. That is the same thing. Pennies would react with oxygen in the same way that the Statue of Liberty did, and there's little bits of green on them because they are having a reaction with the oxygen, and it is something permanent. You can't take it back. It will never go away. You just have to scrape off that part of the metal. All right, so chemical changes. All right, what happens to metals left outside? They're going to rust. That is a chemical change. Many chemical changes happen during cooking. When you take a raw egg and you put it on a hot pan, a permanent change in the egg is going to take place. Once you've cooked the egg, you can never turn it back into a raw egg again, no matter how hard you try. That would be an example of a chemical change. Chemical changes are usually permanent. They cannot be reversed. Once you've done the chemical change, it is what it is. If you put a piece of dry wood into a fire, it's going to obviously burn. You'll never have that piece of wood again. It's going to turn into ash and charcoal. And then that's it. There's no more wood. So these are things that are permanent, as mentioned. Another example is if you were to take flour, sugar, egg, chocolate chips, and other ingredients and mix them, you're going to get chocolate chip cookies if you bake them. This is a permanent change to those ingredients, and once you've baked the mixture, it will create a new form of matter that has very different properties to the original ingredients. So, for example, if like these cookies, once you've baked the cookies, you're never going to get the flour out again, the sugar, the egg, the chocolate chips. They're now all together into this new form of matter that has different properties. What does flour taste like? Flour does not taste very good by itself, whereas a chocolate chip cookie is very sweet. Flour is powdery, whereas a chocolate chip cookie is not. So you've actually changed the properties, the property of the ingredients to create something new. So chemical changes happen because of chemical reactions. So here we go. These are some examples of chemical reactions. A banana changing from ripe to rotten is a chemical reaction. Once the banana rots, you can never turn it into a ripe banana again. Ingredients being mixed together to create baked goods. Again, just like the cookie example, you can never take those ingredients out of that baked good and put it by themselves again. When the leaves changed color during the fall is an example of a chemical reaction. Or the color of a marshmallow changing while you roast it. The marshmallow will never go back to being a raw, uncooked marshmallow before. Each of these changes happen because a chemical reaction is taking place. Then I have a video here.
No matter where you are or what you are doing, Things are changing all around you. Whether it's plants growing or logs burning, or even if you're just
No matter
eating
where
food,
you are
the
or what
materials
you are
around
doing,
you are changing
things
in
are
size,
changing all
shape,
around you.
and structure,
Whether it's
releasing
plants
or
growing
absorbing energy
or logs
and
burning,
creating new substances.
or even if you're just eating food.
In chemistry,
The materials
most
around you
changes
are
are divided
changing
into
in
two
size,
categories:
shape,
physical
and
changes
structure,
and chemical changes.
releasing or absorbing energy, and
A physical
creating new
change is something
substances.
that changes the physical properties of an object or
In
substance.
chemistry,
like
most changes are
size,
divided into
shape,
two
or
categories:
form.
physical changes
Cutting a
and
piece of
chemical
cloth
changes.
is an example of a physical change.
A physical
Even
change
though
is
the cloth
something that
changes
changes
shape
the
and size
physical
when it is
properties
cut,
of an object or
it does not
substance,
create a
like
new
size,
substance.
shape,
It's
or
still
form.
cloth.
Cutting a piece
Even
of
if the
cloth
pieces
is
of
an
cloth are
example of
sewn
a physical
together and made
change.
into a shirt, only
Even though the
physical
cloth
changes
changes
have
shape and
occurred.
size when it is
The
cut,
shirt is still
it
made
does
of the
not
same
create a
substance
new
as the original
substance.
cloth,
it's
just
still
in a new
cloth.
form.
Even if the pieces
Another
of cloth
type
are
of
sewn
physical
together
change
and
involves
made into a
changing
shirt,
states of matter,
only physical
and water
changes
is a
have
great
occurred.
example of this.
The shirt is still made
Ice
of the same
melts and
substance
becomes
as the
water,
original cloth,
and water
just in a new
evaporates to
form.
become steam. But no matter its form,
Another type of
the water
physical
is
change
still
involves
water.
changing states of matter.
One way we can tell
And water
this
is
is
a
a
great
physical
example
change
of
is that the
this.
change can be undone.
Ice melts and becomes
Water
water,
vapor can condense
and
back
water
into liquid
evaporates
water,
to become steam.
and liquid water can be
But no
frozen
matter
back
its
into
form,
ice
the
without
water is
changing
still
to
water.
a different substance.
One way we can tell this is a physical change is that the change
In
can
fact,
be
many
undone.
physical changes can be undone.
Water vapor can condense back into
For
liquid
example,
water,
we know that
and liquid
dissolving
water can
sugar
be frozen
into
back
water
into
is a
ice
physical change,
without changing to
because
a different
even though the
substance.
sugar and the water are mixed together, they do not combine and create
In
a new
fact, many
substance.
physical changes can
They
be
are
undone.
still just sugar and water,
For
and
example,
they can be
we
separated
know that
from each
dissolving
other.
sugar into water is a physical change,
Not all
because
mixtures
even though
are
the
as
sugar
simple to
and the
separate
water
as
are
sugar
mixed
and
together,
water.
they do
When
not
you mix
combine and
butter,
create a new
sugar,
substance.
flour,
They are still
and
just
eggs.
sugar and water,
There is not a
and they can be
practical way to
separated from
separate
each
them
other.
again. But it is still only a physical
Not all
change.
mixtures are as simple to
The
separate as
chemical
sugar and
change
water.
occurs when you put
When
your
you
mixture
mix
in the
butter,
oven and
sugar,
add heat.
flour, and eggs. There is
Baking
not
has
a
many of the
practical way to
indications
separate
of a
them
chemical
again,
change.
but it is still only
The
a
mixture in
physical
the oven
change.
absorbs heat.
The chemical change
It also
occurs
changes
when you
color
put your mixture in the
and
oven
produces an
and add
odor.
heat.
Gases are released,
Baking
which is
has
what helps
many
the
of the
baked goods to
indications of
rise.
a chemical change.
Finally,
The mixture
this
in the
change
oven
cannot be
absorbs
undone.
heat.
You can't
It also
unbake a
changes
cake.
color and produces an odor.
Chemical changes occur when the particles
Gases are
of two or
released,
more substances
which is what
are
helps the baked
rearranged to
goods to
form a
rise.
new substance.
Finally,
For example,
this change
when
cannot
you
be
burn
undone.
wood, the wood
You
is
can't
transformed
unbake a
into
cake.
a new substance. Ash.
Chemical changes occur when the particles of two or more
Just like in
substances
baking,
are
this
rearranged
change
to
cannot
form
be
a new
undone.
substance.
Also,
For
like
example,
the cookies,
when you burn
the wood changes
the
color,
wood is transformed into a
releases
new
gases,
substance,
smoke,
ash.
and produces an odor.
Just like in baking, this change
Unlike in
cannot be
baking,
undone.
this chemical change releases heat
Also,
and
like
gives
the
off light.
cookies, the wood changes color,
Chemical
releases
changes
gases,
take place all around us.
smoke, and produces
Metal
an
rusting,
odor. Unlike in
fireworks
baking,
exploding,
this chemical change releases heat and gives off light.
fruit ripening,
Chemical changes
and
take place
digesting
all around
food
us.
are all
Metal
examples
rusting,
of chemical changes.
Fireworks
Here are some
exploding,
clues to look at if you're not sure whether something is a chemical or
fruit
physical
ripening,
change. Chemical
and
changes
digesting
always form
food
a new substance.
are all
They may
examples of
absorb
chemical
or
changes.
release heat.
Here are some
Sometimes
clues
a
to look
chemical
at if you're
change will
not
cause
sure
a
whether
change in
something is
color,
a chemical or physical
produce an
change.
odor, create a
Chemical
sound,
changes always
release
form a new
gases,
substance.
or produce light.
They may absorb or
Chemical
release heat.
changes usually cannot be undone.
Sometimes a chemical change will cause a change in color,
Physical changes
produce
do
an
not
odor,
form a new substance.
create a sound,
A physical
release
change may
gases,
change the shape
or
or
produce
size
light.
of an object. It may change
Chemical
the state
changes
of a
usually
substance's
cannot
matter.
be undone.
Many physical changes can
Physical
be undone
changes
in
do
some
not
way.
form a new substance.
In a physical change,
A physical
you
change
end
may
up with
change the
same
shape or
substance you
size of
started
an
with,
object.
even if it looks
It may
different.
change the state of a substance's matter.
I
Many
hope you
physical
enjoyed
changes
learning
can
about
be
physical
undone in
and
some way.
chemical changes today.
In a
Look
physical
around and
change,
see
you
if you
end
can
up with the
identify
same
the physical
substance you
and
started
chemical
with,
changes around
even
you.
if it looks different.
Goodbye till next time.
I hope you enjoyed learning about physical and chemical changes today. Look around and see if you can identify the physical and chemical changes around you. Goodbye till next time.
All right, so that's the end of the presentation. The only thing I want to mention now is when you are your science assignment over this, there is another worksheet where there's 19, I believe. I can't remember if it's 19 or not. Anyway, there's several different examples of physical and chemical changes, and there's a blank beside each example, and you are just going to write chemical or physical change on it. And then at the bottom, I think I have you answer like 4 questions about coming up with your own example or giving your own definition for each type of change. If you have questions with that assignment, you can ask me on Zoom. Otherwise, you should have been able to finish your video worksheet over all of this stuff, answering the questions that went along with this video. If you have any help with that, of course, ask me on